Welcome everyone and welcome to our sessions on artificial intelligence. So in the previous sessions we did some basic image processing operations as well as some morphological image processing operations where we tried to alter each and every pixel of the image. That is nothing but we had a filter which would go through this entire image that would take care of the entire image, and you could actually form the whole image processing part. So that is what we actually tried. So morphological image processing are cases in which you take this entire image and you have a small filter which passes through the length and breadth of the image to complete the whole process. That is nothing but each and every pixel will get altered when this particular filter passes through the whole image. So now what we are trying to do is pretty simple. So the next operations that we'll be trying to do today are blurring operations, thresholding operations, contouring and drawing operations. So what is a blurring operation? We'll discuss first. So you have heard about blurring and you have experience about blurring in your real life also. So whenever you have an image with you, so whenever you take a picture with the camera, sometimes if the image is not focused, actually what is happening is the image is not getting depicted correctly or not taken correctly. That is why you can't see the details in the images. So how you cannot see the details in the images is the structure of the image is not clear. So the best example of this is the best example of blurring. So even though I've taken the picture, I cannot see the text properly. So sometimes what happens is blurring is a necessary thing. So if you have too much of details in the image, if you want to remove some details of the image, what you need to do is you need to actually blur some information. So that is why blurring, even though it has a lot of negative impact, that is nothing but whenever you are trying to blur, you are losing out on information. But the major thing is whenever you are trying to do some operations of hiding the data or removing some details out of the image, blurring is also important. So that is why we shouldn't tell that blurring is a negative operation, so it is not necessary. But actually in some cases, whenever the image is too detailed, so you need to do that blurring operation. So how actually blurring happens is pretty simple. So I will consider a case of a 3x3 image. So what is a 3x3 image? It has 3 rows and 3 columns. So in a normal image, you will have different intensity values. So you have 255, then you have 0, then you have 156. So if you come down, you will have 12. Then you will have 34, then you will have 200. So similarly, your intensity will vary with respect to low and high. So you have varying intensity values of low and high values. So this is a regular image or a normal image. So when you try to blur an image, what is happening is you are losing out on the detail. So how are you losing out on the detail? So you can see this image, for example. So even though both the images are same and almost both the images are same, the major thing is here you can't see the detail at all. Here you can see the detail. So what is happening is you can see the difference in the pixels and the intensity of pixels in a regular image. So you can make out the difference in the intensity of the pixels and you can see how actually the image is getting formed. So even though the same RGB value is there in that image, you can see the color of the image, you can see some of the structure being formed, but there is no sudden increase or sudden decrease in the pixel values. So if there is sudden increase or decrease in the pixel values, it would look like this. So there is 255, there is 0, 156, 12. So the pixels are varying. So if you consider a blurred image, it would be like 130, 132, then 134, then it will be again 128. So you will have pixels which are ranging on the same intensity value. So there is no sudden change in the pixel value. So that is what is causing the blurring effect. So how is blurring effect being caused is there is no sudden increase or decrease in the pixel intensity value. So only if you have sudden increase or decrease in the pixel intensity values, then you can see a detailed image. So if you can't make out that, then you can't see a detailed image. So blurring is just an example of averaging. So you can call blurring also called as averaging. So what you are trying to do is you are taking an average of all these pixels and replacing all this pixel value with the average value. That is how you are trying to get in a fairly non-detailed image that is nothing but a blurred image. You are not able to perceive any details out of this. So how can we do this blurring is a question that we have. So we can do blurring in 3 ways. So one is called as Gaussian blurring. So the next one is called as your Okay, and the next one is called as your median blurring, and the last one is called as bilateral blurring. So what is median, what is bilateral, and what is your Gaussian blurring? We'll try to understand. So Gaussian blurring works on the principle of the Gaussian function. So what is a Gaussian function? So whenever you consider a Gaussian function, so it is a fairly simple function to understand. So you have the Gaussian function given as g of x. So g of x will be nothing but 1 by square root of 2 into pi into standard deviation square. Okay, you have this 2 into pi into standard deviation. So then you have e power x square plus y square divided by 2 into standard deviation whole square. So what is this standard deviation and how do you define this standard deviation is the question. So if you are all aware of statistics, so the basic concept of statistics is standard deviation. So how to define the standard deviation? So to understand standard deviation, we need to understand the mean and median first. So what is a mean and what is a median? So if I have the numbers 1, 2, 3, 4 and 5. So what is the mean of these all values? So mean is nothing but I should add all these values. So 5 plus 4, 10. So 15. 15 divided by 5. So 15 is my total sum. So my mean is nothing but 5 values. So the answer will be 3. So 3 is the mean of all these values. So 3 is the mean of all these values. So then you need to calculate your that is nothing but your standard deviation. So the formula of standard deviation is pretty simple. So the formula of standard deviation is you have the values of your n. So you have your values of your n. So what is the value of your n that you are trying to do here? So when we come out for the standard deviation, we have n is equal to 5 here. So n will be equal to 5. Because number of terms is 5, but standard deviation is given by the formula square root of each and every term, that is nothing but x minus x bar is the mean divided by your nothing but n minus 1 value. So this is what is your standard deviation. So you are trying to calculate the standard deviation of all the pixel intensity values, whether it is R, G and B. For all the three you are trying to calculate. So after finding out your standard deviation, you are trying to replace that standard deviation with a matrix. So you have a matrix called as Gaussian matrix. So this Gaussian matrix you are trying to use it amongst the image. So step 1 is calculate the standard deviation. So then you try to find out the Gaussian matrix here. That is nothing but find out using the Gaussian function, find out the Gaussian matrix, apply it to the whole image like a morphological image processing part. So how do you apply it to the whole image? I told you there is a small filter which goes about the entire image and finds out the data. So that is what is your morphological image processing operation. So Gaussian function is pretty simple. You have this Gaussian function. Using that Gaussian function, you are trying to find out the matrix. So very important. You at the end of this function, what are you trying to do? You are trying to find out the Gaussian matrix. So what is Gaussian matrix? When you use this function, when you find out this function g of x, then you are calculating the Gaussian matrix. So this Gaussian matrix, you are trying to actually use it everywhere. So this is the Gaussian matrix. So this Gaussian matrix is the filter, or you can call it as a Gaussian filter also. That is also not a problem. So then after calculating that, you can apply it to the image and the image is getting blurred. So this is one of the operations that you can try to do. So the next thing you can try out is called as the next basic thing that you could try out is nothing but your median blurring. So median blurring is pretty simple. So when you have again the same value 1, 2, 3, 4 and 5, what you are trying to do is you are trying to take in the average. So average is nothing but your 15 divided by 5, that is nothing but it is equal to your 3. So that is your average, or what you call as bilateral blurring. So average blurring is also called as bilateral blurring. So this is called as average blurring, where we take in the average of the values. But what is median blurring is whenever you arrange the value. So if I have it in 5, 2, 3, 2 and 1 and 4, you need to arrange it in an orderly way, either in an ascending order or either in a descending order. So when you try to arrange it in a descending or ascending order, the middle value is called the median. So similarly, when you try to arrange all the pixels inside an image in an arranging ascending or a descending order, so the middle value will be median. So all the pixels will be replaced by your median value. So then you will be able to get that blurring effect. So this also it happens with the help of a filter. So we'll not take in the entire image. If you take in the entire image, the whole image will be a total mess. So you're taking out small filters or you're taking out small matrices of 3x3 or 5x3. Inside that you're calculating median and doing it. Here also you're not doing it for the entire image, you're just doing it for a 5x5 or a 3x3. So bilateral is also called as average, where you take in the average of the pixels and then you try to create a filter using those average values, and then you try to pass it through the entire image. So all these are nothing but filters. So they are nothing but either a 3x3 filter, either they are 5x5 filter. So all these are nothing but filters. So they will help you go through the entire image in the form of a small filter and help you do all the operations. So this is with the 3 types of blurring which we actually have. So how to implement the blurring? It is pretty simple. So we'll just study about it. So I've come to my Python program. It is pretty simple. So I will import my CV2. So import CV2 will import my OpenCV2. The first step is I should read my image. Image is equal to cv2.im read. So I should read my image. How to read my image? I need to give the name of the image. So the name of the image is leaf.jpg. So I've read the image properly. So let us print out this or display this image to show that it is not blurred before only. So I should name the window that is called as leaf. So the variable which has my leaf.jpg is image. So I will try to use it. So this is the image. So this image is not blurred at the starting. So it is not blurred now. So it is a clear, correct image. So if you want to do the blurring operation, so first method is called as Gaussian blurring. So in Gaussian blurring, what you want to do is you need to use the function. I will create a variable called Gaussian. You can create any variable. That is not a problem. So cv2.Gaussian blur is the function. So cv2.Gaussian blur is the function. So what you want to blur? I want to blur my leaf image which is stored in the variable image. So then I want to actually have this particular size of the particular filter. As I told you, it is a morphological operation where the operation is happening like this. So we have this kernel filter or a matrix which will go through this entire thing. Then you are going to get a result. So that is what is happening. So you need to mention the size of the filter. So I will mention it as 7x7 filter. You can mention it as anything, not a problem. So 7x7 is my filter. Then I need to mention the standard deviation. I already told you it is defined by the standard deviation. You can give it as 0 because 0 standard deviation is a regular one. If you want to do your own math and if you want to calculate the standard deviation, you can do it on your own. So that is not a problem. So you can mention the standard deviation, or it will by default it will take 0 as the standard deviation. So standard deviation, it helps you to refine your image. So if you are giving different values of standard deviation, you are able to refine your blurring. So to show the blurring, so cv2.im show, and blur is the window name. If I want to show the image, it will be Gaussian because that is the Gaussian. Gaussian is a variable which has stored my Gaussian blur of my image. So 7x7 filter I have applied, standard deviation of 0. So then if I want to display this, so you can see that slightly there is blurring. So when I want to compare this and this, you can see that there is slight blurring happening between the two images. You can notice it, the sharpness has gone. So that is what is your actual blurring operation. So if you don't want to see a detailed image, if you want to see a blurred image, you can use that. So if I want to increase my intensity, so I will use it, or increase my particular matrix size or filter size, I will do it for 77x77. See, if I use it for a very big filter, so it took a very big filter, 77 pixels cross 77 pixels, then it calculated the Gaussian function of those. So that is why it is blurring the image at a very bad scale. So if you are using a very large value of your filter, so if you are using filter a larger value, what happens is it will take 77x77 pixels, then it is trying to find out the average. So if I use a very small one, like if I use a 1x1 filter, you won't even make the difference. So the same image it will display. So that is the thing. So if you use a 1x1, you won't even notice the blur. So that is the whole thing about blurring. You should choose which is the actual size, that is the width and height of the particular filter that you want to use. If you want to change the standard deviation, you can change the standard deviation also. So if you are changing the standard deviation, if you are not using a bigger filter, you won't notice the difference. So if you use a 10x10 filter, so then if you are increasing the standard deviation, these are all slightly like, okay, so the thing is the standard deviation must be a very small quantity. It shouldn't be a large quantity. It should be in points. So when you have it in points, you can make out the difference that is between the blurring and the everything, the whole operation. So this is what we are able to do here. So what we are trying to do is we are trying to use this entire image and we are trying to create a blurring operation using the Gaussian blurring operation. And one more thing, while choosing the values of your nothing but your kernel, what you need to think is you need to see how much big is your image. So that is a very important thing. My image is 2048 pixels by 1048, so I can choose a bigger bigger dimensional kind of filter. But if your image is only 50 cross 50, you can't choose it. You need to choose a small thing. So that is how it is happening. So you can't choose a filter which is bigger than the image. Obviously it should be equal to or lesser than the whole image. So that is one part. So then coming to the median point, so median blur is similar, CV2 dot median blur. So this is also a similar operation. So if you want to do it, it is very simple. So CV2 dot median blur. So then you have the image, that is the whole point where you are where you have all the variable that is getting stored. So image is the variable where you are storing the entire leaf. That is nothing but the leaf image. So then you need to mention the size. So here the size is not a matrix. You can just mention a size 5 or 10. So the mentioning the size, what is happening is median blurring or the median matrix is always a square matrix. In case of your Gaussian matrix, you can take a rectangular matrix also. So in case of median, so it is just a square matrix that you can take. So that is why you don't need to mention the column. If you just mention 5, it will be understood as 5 cross 5. So median blur image and 5 is nothing but a 5 cross 5 filter. So CV2.im show, what is the thing that you want to show? That is nothing but a blurred image. So I will name it as blur. So then what I will do is I will use the variable median to display the median format. So you can see here again they are able to see the blur. So if you use a 5 size, so you are able to see the blur. Again, if you use 20 sizes, okay, 20 is a very large value, so it is getting out of dimension. So I will use 10. Okay, 10 is also not a problem, so you can use 6. Yeah, the reason why we are getting an image, so if I type in 6 or something, so the reason why we get an error here is, so the thing that you need to understand while using your median blur is, median blur, the value of the kernel can be 1, 3, 5, 7. It should be an odd number which is greater than 1. So if I give 3, it will display the output. So if I give out 5 also, it will display the output. So similarly, if I give a 7, it will do the blurring operation. So any odd number greater than 1, it is getting accepted. So that is what is the case with your filter. Your filter size must be an odd number and it must be greater than 1. So that is why we are getting error here. So the reason to solve this error is use odd numbers which are greater than 1. You will not have any problem with that. Okay. So similarly, the next thing is our bilateral blur. So where we are taking in the average of our particular colors spaces. So that is what we are doing in bilateral blur. So we have bilateral function here. So if you want to use bilateral blur, it is pretty simple. So it is called as bilateral filter also. So the function is bilateral filter. So you can use this bilateral filter, then you have the image. So after having the image here, you need to give 3 things. So one is the filter size. Either here also it is the same. Either it is a 3, 5, odd number greater than 1. So I will give a 9 here. So after giving 9 here, what we'll try to do is, after doing that, we have 2 more things to do. So what are the 2 more things to do is we need to select the area. So here we are selecting the particular thing, that is nothing but how much space should be the filter. So then we need to select what is the area. So what is the area that we'll be actually covering in one iteration is the thing that we'll be selecting. So this area you can select it as like around 75, so that is also not a problem. So any values that you want, you can give. So around 75. So the next thing is the color space. So which color you are trying to blur. So bilateral blurring, what it does is actually it takes the average of all the values and does it. But it also has a specific speciality to this particular filter. So what is the speciality to this blurring is, you can even choose the color domain for which you want to do it. So if you want to do it for darker color domains, that is nothing but you can choose values from 0 to 20. So if you're doing it for white domains or like brighter color domains, you can choose it somewhere around 240 to 250. So that is what it does. So you can rename this as bilateral and you can try to see the output. So you're getting the bilateral blur here. So that is what you are able to do. So what you need to practically try and do is pretty simple. So you can do a few things first. So what is the first thing is, you need to select the image. Then you need to select what is the size of your filter. So you can choose any odd number. So I can choose 71 is an odd number which is greater than which is greater than 1. You can choose that information also. So it depends. So what is the size that you want to choose? So after choosing the size, so if I use 71, the entire image is getting blurred because I've chosen a bigger number. So then what is the area also? So if you want to choose the area, you can choose around 200, 100, 50 or 5. So that is also not a problem. So the average value that people choose is around 75. So then the colors also, if you choose closer to 0, so you can see much more darker version of the entire image because it is trying to blur the lighter versions, like it is trying to blur the lighter versions and it is even getting more details into the darker version. So three things here. The first thing is nothing but your first part is nothing but the size. So you can select the kernel size. So then you have the space or the area for which we are targeting for one iteration. So we call it as dimensional area or the area space, what we call it. The approximate value would be 75. So then you could even look for what is the color space that you are looking at. So color space, it can be 0. So if it is 0, you will get all the details. So the entire details you might get. So then if you choose 255, obviously you will not get the entire detail, so it is getting blurred here. So then you need to even tell what is the size of the kernel. So if you increase the size of the kernel, obviously the blurring will have more effect rather than a small size kernel. So this was the whole concept about blurring and its operation. So three types of blurring you can look at: Gaussian, median and bilateral. So depending on the purpose, depending on what a type of blurring that you need, you can choose any one of these. Hello everyone. So the topic that we'll be discussing right now is called as thresholding topic. So what is thresholding and how exactly thresholding is helping you in image processing is very important to understand. So thresholding is nothing but whenever there is an image and you are converting all the intensities to a threshold value. So how exactly thresholding looks like, I want to show you. So thresholding looks like this. See, basically when you want to do some thresholding operation, always you need to consider the fact that this thresholding operation is happening on a grayscale image. So any image that you are considering color image, you need to first convert that into a grayscale image. So after converting that image into a grayscale image, so the next thing that you want to do is pretty easy. You need to convert it into the thresholding factor. So what is thresholding? It is pretty simple to understand. So when you have the different values of intensities of gray, so when you take in a grayscale image and there are different intensity values of gray. So there is light gray, dark gray, absolute white and very dark black colored image, like content is there here. So what is happening in thresholding is it is converting your grayscale image to a binary image. So what is a binary image? So binary image is pretty simple, or a black and white image to be specific. So what it is doing is, if an intensity is greater than a particular threshold. So you have your black represented by 0, white represented by 255. So what I will do is I will set an intensity threshold stating that if my values is greater than if my threshold, I will set the threshold as 150. So if I have values of intensity greater than 150, so make it white. So this light gray values are becoming white. So if my values of intensity are less than 150 or something, make it black. So light gray values or like darker gray values or close to black values are becoming entirely black. So this is the whole important concept that you need to understand. So thresholding is the concept where you are trying to convert a grayscale image into a black and white image, or an image which contains only black colored intensities and white colored intensities. So these kind of thresholding operations we can try to do. So in thresholding operations, we have multiple thresholding operations, so which we will discuss. So the first type of thresholding is called as binary thresholding. So what is binary thresholding? So as we saw now, so the example which we saw directly right now, this is the example of binary thresholding. So what exactly we are doing in binary thresholding? We have our intensity values. Lighter intensities values are thresholded to white. Darker intensity values are thresholded to black. So that is what it is being done here. So that is the basic definition of our binary thresholding. So how to express binary thresholding? It is pretty simple. So if intensity values, what there will be intensity values are there. So they will be either converted to maximum value. So maximum value, you can set the maximum value. It is not 255. Generally we set it as 255. So this value can be set. So intensity values will be set to like max value if intensity values is greater than threshold. So if intensity value is greater than threshold, then it will be set to max value. Else it will be set to 0. 0 is nothing but black if intensity is less than threshold. So this is the binary thresholding. The concept is called as binary thresholding. Okay, binary thresholding, the intensity value will be equated to maximum value if intensity is greater than threshold. So maximum value you can set. Generally we set it as 255. So you can see this example. Intensity value if it is greater than threshold. So these light values are greater than threshold. So they are set to max value. 255 is what? White. So all these coins are becoming white. But if the intensity value is less than the threshold, what are they getting set to? They are getting set to black. So this is binary thresholding. This is the one that you need to understand. But there is also another thing called as inverted binary thresholding. So what is inverted binary thresholding? The reverse of it. So inverted binary thresholding is a simple concept where intensity values is equal to is equal to max value or your 255, whichever you set it. So if it is equal to max value or 255, if intensity values are less than threshold, so it is the reverse operation now. So if intensity values are less than the threshold, so if intensity values are less than threshold, so then it is equal to 0 if intensity values are greater than threshold. So this is inverted binary thresholding. What is happening here? Intensity value will become maximum value, that is white, if the intensity is less than threshold. So if I have dark gray images, so that will become white. So if I have more lighter images, that will become darker. So it is inverted. So it is nothing but a NOT operation. So whenever you have a NOT operation, what is happening? It is getting, it is the reverse operation of binary thresholding. So a best example is this apple. See, darker pixels are getting converted into your lighter pixels, that is nothing but your gray values. So maximum value is not set to white. If it is set to white, it will get converted to white. But these darker values, see, darker values are getting converted into pure white. Okay, so then you have the other values which is getting converted into gray values. So the background which was light got converted into black. So it is inverse. So pure white is getting converted, it is greater than, pure white color is 255, it is greater than threshold. But if it is greater than threshold, what happens? It is getting set to what? It should be set to 0. So what is 0? Pure black. So if it is less than threshold, so if intensity is less than threshold means you are coming into these darker values. So it should be set to maximum value or 255, that is white. So it is the reverse operation. So if you have dark colors will be converted into white, light colors will be converted into black. So that is what is your binary thresholding operation. So this is your binary thresholding or inverted binary thresholding operations. Okay. Then we have other two examples. Okay, so the next type of thresholding that we'll be looking at is called as truncated thresholding. So what is truncated thresholding? Okay, so truncated thresholding is a kind of thresholding where if the intensity value, so if you have the intensity values will be equal to the, okay, so earlier whatever we did was equal to the maximum value. So the intensity value will be equal to the threshold value. So if intensity value is greater than threshold. So if intensity value is greater than threshold, so then it will be equal to the intensity value. Otherwise, it will be equal to 0. No, it will not be equal to 0. It will be equal to the source intensity or the intensity, original intensity values. So basically what we are telling right now is we have a concept called as truncated thresholding, where you have the intensity values. So the intensity values will be equal to the threshold values if the intensity value is greater than the threshold. So if some values are greater than threshold, then they'll be equal to the intensity values. In earlier cases, what we had is we had it equal to the maximum value. So we are truncating that and we are making sure that the maximum value doesn't the threshold value doesn't reach the maximum value. It will be equal to the threshold value itself. So if we have a value that is nothing but an intensity value of 255, so since our threshold value is 150, so since our 255 is greater than 150, so this will be equated to 150. Because any threshold or any value which is greater than the threshold will be equated to threshold. So that is what is happening in our truncated thresholding. But if it is somewhere around, like if our value is somewhere around 120 and the intensity or the intensity threshold is 150, it remains as 120. So that is double equal to 120 only. So if your intensity values are greater than threshold, so then they will be equal to the threshold only. Otherwise, they will be equal to the original intensity value. So this kind of thresholding is also available in case of our thresholding concept. So after that, we have the next concept that is nothing but 2-0 thresholding. So we have a concept called as 2-0 thresholding. So what is this 2-0 thresholding doing is pretty simple. So your intensity values will be equal to, so your intensity value will be equal to original intensity values, will be equal to original intensity. So if your intensity values is greater than your threshold values. So if your intensity value is greater than the threshold value, so then it becomes the original intensity. So there will be no change. If your intensity values are greater than threshold, there will be no change. The same intensity values will be retained. But if your intensity values is less than threshold, so then they will be equated to 0. So what is 0? It is pure black. So if intensity values is less than threshold. So this is called as threshold or 2-0 thresholding. So what is 2-0 thresholding? So we have one threshold that is nothing but 150 here. So if my intensity values are greater than 150, that is 165, so they will be equal to 165 only. So they won't be reduced to the threshold values. But if your intensity value is 140, then it will be reduced to 0. So that is very important. So if it is 165, it will remain as 165. If it is 140, it will be reduced to 0. So this is the thing about 2-0 thresholding. The same way we have 2-0 inverted thresholding. So what is 2-0 inverted thresholding? So it is the reverse operation. So you have 2-0 inverted thresholding. So this is the exact opposite. In 2-0 inverted thresholding, what is happening is pretty simple. So your intensity will become 0 if your intensity is greater than the threshold values. But your intensity will become the original intensity if your intensity is less than the threshold values. So for example, I have chosen my threshold as 150. So if my intensity is 165, so then it will be equated to 0. So this will be equated to 0. So if my original intensity is 135, so since this is less than the threshold, it will be equated to 135 only. So this is called as 2-0 inverted thresholding. So 4 type of thresholding we saw. First one is binary, the second one is inverted binary. Then we had an example of truncated thresholding. Then we had 2-0 and 2-0 inverted thresholding. So these are the 4 type of basic thresholding operations we have. So what we'll do is we'll just simply try to implement those thresholding operations using our OpenCV functions, and then we'll try to understand in practical what is exactly happening in our entire program. So again I'll be choosing my image that is nothing but leaf image. So with this leaf image I'll be trying to do my all inverting and that is thresholding operations that I told you about. So how to start with this is pretty simple. So we'll go with our program. So we'll import CV2. So import CV2 is nothing but we are importing OpenCV. So that is done first. So then what we will try to do is we will try to read the image. So it is a very simple command. Image is equal to cv2.imread. So image is a variable. You can name it as anything. So it is not a mandatory factor. So cm2.imread is the command. cv2.imread is the command to read the image. What is the name of my image? Leaf.jpg is my image. So leaf.jpg is my image. So this I am trying to read. Okay, so what I will try to do is I will try to show the image cv2.im show my image, which is nothing but I will name my window as leaf. So that is done. Then I need to name my image. So this is the exact syntax. So now if my program loads properly, so I will be able to show my leaf image. So leaf image is shown. So this is done. The image is able to take its place. So this exact operation is done. So next operation that we want to try out now is the thresholding operation. But always I have told you, for thresholding we need to use the grayscale images. We can't use the color images. Why we can't use the color images is, so if you want to threshold, if you want to convert any image to black and white using thresholding, the main problem is you can't use your color images. So color has red, green and blue coordinates, that is nothing but red, green and blue points, which will make it very difficult for an image to transform into black and white. That is why it is a compulsion to convert your image to a grayscale image. So how do you convert your image to a grayscale image? There are two options. While taking the input only, you can give an option called as 0. So that will give an option of taking in a grayscale image. So you have this cv2.im show. So then I can name it as leaf. So then if I display that image, that will give me a grayscale image. So two options are there. One is taking it as 0 and taking it as a grayscale image. So this is option 1. So if I want to take in option 2. So if I want to use option 2, it is pretty simple. So we can convert the image to a grayscale image. So what I will do is I will name a variable called as gray. So gray is my variable. So how do I convert it? cv2.cvt color. So C is capital, COLOR for color. Then we need to mention which is the image that we are trying to convert it into grayscale. So the image variable is image. Then we need to use the function called as cv2.color_bgr to gray. So what is this bgr to gray? So bgr is nothing but color, blue, green, red. 2 is nothing but how you use while texting. So that is nothing but a shorthand language to gray. So what we are trying to do is we are using a function to convert our image to gray image by using this function. So what we will try to do is we will just use this cv2.im show option to display our gray image. So we will use gray to display our gray image. So let us see whether the image has been able to get converted into grayscale image. So my problem is it is cv2.color_bgr to gray. Yeah, so now it is converted successfully. So this is telling you that I have converted whatever image that I have taken as an input to a grayscale image. So this is the basic conversion that you do. Two ways, either you can give it 0 as a input in the cv2.im read or use this function. Now we have converted into the grayscale image. So what we need to do is we need to use the function of thresholding. So how do we use the function of thresholding? It is pretty simple. So here what is the important factor is this thresholding function has two return values. So what is return value? Whenever you have a function, the function will return something. So if this function, for example, so this function is converting your colored image to a grayscale image. What is it returning? It is returning a grayscale image. Okay. So similarly, this thresholding function will return two things. One is the Boolean value, whether it has done the thresholding operation or not. So that is the Boolean value. The other thing is the thresholded image. So that is why I can't use a simple variable called as thresholded and use it. So what I will do is I will use the other option, that is nothing but I will use two variables. So one is a return type where it will return a true or false. The next one is my image variable which will store the thresholded value. So understood this? Very important. Other functions are returning only one value, that is the image value. So if you are converting it to grayscale to binary or any like color conversion or any function that you used till now was returning only one value. So what was that one value? That is nothing but your image value. But this is an function that will return two values. So the type of the function is such that it is returning two values. So what is the value it is returning? So this one is a Boolean and this one is a image data. So image matrix. So these two are helping us to convert our data into threshold data. So this is nothing but a simple function. So this we don't need to worry about. Okay, so we are not worried about the Boolean value, we are just worried about the threshold value. So how do you convert it? CV2 dot threshold. Okay, so CV2 dot threshold is done. So then what is the important thing? For which image I want to carry out the thresholding operation? So that is nothing but the gray image. Then I need to set the threshold value. I will set my threshold value as 120. So then I need to set the maximum value. So what is the maximum value that you want to choose? 255 can be set, 200, 240, any value which you, any intensity value which you want to set, you can set it. So 255, I am choosing it as my maximum intensity value. Then I told you there are four types of thresholding operations. So which are the four types? Threshold, binary inverted, truncated, 20 and 20 inverted. So the first one is threshold binary. So the function to use threshold binary is CV2 dot threshold and you will have underscore binary. So CV2 dot threshold underscore binary will convert that particular thing into the thresholded binary concept. So this is what it is doing. So it is converting into your binary value. So what are you getting exactly? I will use my CV2 dot imshow. CV2 dot imshow to show the particular image. So how will I show it? I will use thresh1 is nothing, that is nothing but my image part. I don't want the return part to be shown, but I need to even mention my window name. Window name is nothing but binary thresholding. So you can name it as binary. Anything you want, you can name it and you can display it. Okay, so what is happening? I am showing my original image also. This is very important to understand. So in this original image, you can see all the lighter gray values are converted to black. So my threshold is 120. So anything which is less than 120 is converted into pure white. So anything which is greater than 120 is converted into black. So this is a binary thresholded image. Very simple to understand. So you can change the maximum intensity values, you can change the threshold values to get different results. But what I will do is I will try to do my binary threshold inverted. So how to do that inverted operation? Just underscore INV. So that will do my binary threshold inverted operation. So binary threshold inverted. Similarly, but it is like a NOT gate. So when you have a NOT gate, so that is better. So if you have a NOT gate, so that is telling you what? The exact operation is reversed. So let us see the output and understand what is happening. Now you can understand lighter gray values have become black. Darker gray values have become white. So that is the reverse operation that is being done. So that is the simple understanding you can get from your binary thresholding inverted operation. So this is just a simple example. Okay. So then what we will try to do is, we will try to do the other three thresholding operations also. So the next type of thresholding that we are looking at is truncated thresholding. So just replace the binary inverted with the keyword TRUNC. So that will start with the truncated thresholding. So it is pretty simple. So you can call it as truncated in the window bar. So then you can try to just print it out. So if you can look at the output, so what is exactly happening is, so anything greater than your threshold. So what is truncating operation? So truncating operations is if your intensity values is greater than the threshold value. So that will be taken as your like the maximum value or the maximum value that needs to be displayed in the picture. So if it is less than the threshold value, it will be taken as the original intensity values as well. So this is truncated. So you can see if it is less than threshold, it is retaining the original like intensities. If it is greater than threshold, it is pushing it to be threshold again. So that is what is your truncated operation. So then you have your 2-0 operation. So what is 2-0 operation? So it is another type of thresholding 2-0. So just name it as 2-0. It is in caps, so that will change it to 2-0 thresholding. So you can just think about that again. So see here. So what is happening here? In 2-0, if the values is greater than the threshold, so then it is pushing it to 0. So if you have values that are greater than threshold, it is retaining. So if you have values that are lesser than threshold, so it is pushing it to 0. So that is what you can see. So values which are lesser than threshold are being pushed to 0. So you can see here only dark values are available here. So that is how your 2-0 thresholding is working. Okay, so then you have an advantage of the last one, that is 2-0 inverted. So you should include an I and V symbol here. So you can rename this if you want to 2-0 inverted. So you can rename it and you can run the code. So you can see here in 2-0 inverted, if it is greater than threshold, so lighter gray values, if it is greater than threshold, it is pushing it to 0. So if it is less than threshold, it is retaining those values as it is. So this is very important. Okay, so the use cases, this is very important now. The use cases of where this thresholding can be used in your practical application. So the first one is your text-based thresholding. So if you are having any text data, that is nothing but old transcripts or any old documents where the text is actually like the text data has become more and more diminished due to the aging of the paper. So in those cases you can do thresholding to see what is the exact text content that you have. So the second case is in the cases of X-rays. So in some X-rays what happens is you are not able to get the exact picture of the bones or the ligaments which have been broken in some cases. So in those cases what you need to do is you need to apply these thresholding principles. So when you apply the thresholding principles, what you are trying to do is you are getting into more and more detail and you're removing the noises. So you have noises or disturbances in the images that are getting removed and you're only able to get the right parts of the image or concentrated parts of the image. So this is the most fact of advantage of thresholding and the use of thresholding in image processing industry.